All right, so we're going to talk here about our properties of logarithms. So these are the properties we should know. The product property says that if you have log base b of m times n, you can separate it out and say that's the same as log b. Anybody? Well, that is what this is, mn. So if I want to separate it out as much as I can, it'd be log bm. What's multiplying the same as?
Plus log m plus log n.
Log bn. Right. Is that what you meant?
Yeah.
So two logs that are added together with the same base can be put together and written as a single log with multiplication. We had these yesterday and we wrote this. But you could also have this and write this. All right, so same thing. Division is subtraction. So we're going to say log bm minus log bn. Okay, and then we've got this power property, which we know by now. You take the n and put it out front. So n times log bm. And these are just some things to know. If you see log b of b to the a power, it's going to be a. Right? I mean, you could think of it this way. If you pulled the a out, you'd have a times log bb. But log bb is 1, right? Because a b to the 1 is b. So those are just a couple things to know. If you see those, just write that. All right. So these are all kinds of problems that you should be able to do at this point. Writing expressions as a single logarithm. Go ahead and try A through D here. You're writing single log. Backwards from up here. Yeah. I'm going to start going over the answers. So, 23. Would you like to tell me the answer to A? Log 512. Right? When you add, you multiply. B is calling on 10. Log 6, 5, because it'd be 25 over 5. C is calling on 30, no 30. How about 26?
What?
26, you got number C.
Log 7
Log 7. Then you said what? To the third, you said?
Yeah.
How'd you get that? Oh, got it. I hadn't looked ahead yet. Because at first, it's x to the 5th over, since it's subtraction, x squared, and then you simplified it to x to the 3rd. Very good.
Is that because of the power property? Like, technically the 5 would be...
Yep, so if there's a number out front, put it on the exponent. Number out front, put it on the exponent, and then we can simplify that. So when you can simplify it, you should do it. That would be our final answer. Okay, how about D, 5? Log 4 15x would be the right answer, right? Because we got 60. The x here is being added, so that gets multiplied. The log 4 is being subtracted, so that gets divided. And so 60x divided by 4 is 15x. All right, very good. So next. Oh, there's an E and F. Go ahead and try those too. And in 30 seconds, I'm going to call the next person. $22. You want E? All right. About 18.
Yeah. Log.
Like so?
No.
Oh. Like that? I see. No, I got it. Because at first you wrote x squared, and then you wrote y cubed, right? But you can't, since they're different variables, you can't put that together, so you would just stop there. All right, log x squared over y cubed. All right, how about number 13 have f? Is that how you wrote it? So, first of all, when you're putting adding together, you put it together with multiplying, right? So this would be a times right there. Okay? Now, this squared goes on, but this whole thing, I mean, really, just to be safe, this is kind of all together. So I think this squared, you know, it's on the whole 5y, so if I put it in parentheses. So now let's put this together. What's 4 times 5 squared? No, because you gotta PEMDAS it, right? You gotta do the exponent, you gotta do this first before you multiply by 4. Log 3 of 100xy. Okay, so this, you know, I did the 4x times the 5y squared, but the 5y both needs to be squared, so that we squared the 5, got 25 times 4. All right, so I got to be careful on that one. All right, now on these, well, this squared goes, you know, it's log 3 of 5y. Like 5y is just a number. So this squared goes on whatever is right here, wherever we're taking the log of.
Right, so but then you just square the 5, you don't square the y.
You do square the y. Oh! I forgot to write it right there. Sorry. Okay. So now we're going to go backwards. If it says expand each logarithm, it's already written as a single log, and we want to make, basically your task is to make this look as long as possible. All right, so separate it out as much as you can. So always the question here is, how many things are being multiplied here? 3, right? 6 and x cubed and y. So our answer should have 3 different logs and they're all going to be added together, right, since it's all multiplied. So we're going to say log 6 plus
log x cubed.
log x cubed, except if I have log x cubed, what should I do with the cubed? Put it out. So we're also going to take any exponents and put them out front this time. So 3 log x plus
Log
log y. All right, so that is, you're expanding it as much as we can. All right, this one, so we've got log 2x, then minus log 2y. Now here's the question. What sign do I put next?
Plus.
So if I put plus, then I put log 2z. If you were doing this problem, would you get this? You wouldn't, would you? If I told you to write this as a single log, you would put the x and the z on top, wouldn't you? Because they're both positive. You would only put the y on the bottom. So this shouldn't be a plus, right? It should be a minus. Anything that's a minus goes on the bottom. All right? So since those are both on the bottom, think the minus is kind of distributing through the bottom there. All right? How many things, this could look confusing at first, but how many things are being multiplied here? Well, I mean, you could think of it as 3 if you think of 3x minus 2 twice, right? Or you could think of it as 2 if you're just thinking 7 and 3x minus 2 squared, right? It just kind of depends on how you look at it. But I'm going to go ahead and go log 7 plus, and then I'm going to pull that 2 out front. Yep, 2 log 3x minus 2. All right, next. What do we think this one is? How many things are being multiplied here? 2. So we've got log 5. So here's the thing. Okay, he said, I thought the negative 5 would go in front. It would if it was like this, because then that negative 5 would be on the whole thing. The negative 5 is only on the x. So this is kind of itself, log 5. And then what would I put next? I could put a plus, but then what would I do?
negative 5.
Negative 5 log x. So I would just write this as minus 5 log x.
Then wouldn't you think to divide it?
Yes, you would. But how couldn't this also be written as, thank you, 5 over x to the 5th? Because isn't that what x to the negative 5th means? It goes on the bottom, right? So this is really the same as this. So if it had been written this way, you would have put a minus. Do you see what I'm saying?
Yeah, actually I do.
X to the negative 5th is 1 over x to the 5th that would go on the bottom.
Because when you have a negative x plus a factor.
Yeah, right. All right. Let's look at this one. Yeah.
It's like a minus, and then it's a negative, so it's kind of like adding. I don't understand.
Okay. So if this was the problem,
Yeah.
what would you would go log, and then you would write 5, and then you would put over because it's minus, right? And then you would say x to the 5th, right? But 5 over x to the 5th is the same as 5x to the negative 5th. So no, I put a plus at first because it's multiplying here, but then I pull the negative out. So plus a negative is really the same as minus. So I mean, if I wrote it like this, it would be correct. But if I just wrote it like this, that would be the same thing, which seems a little easier. Does that make sense? Okay. All right. Next. Got lots of things happening here, right? How many different parts to the log do you think we're going to have? Colton says 5. I think I agree with him, isn't it? 1, 2, 3, 4, 5. The ones with exponents will have a number in front. So let's go. We got log 2 plus 2 log x plus log y, but anything on the bottom will get subtracted. So minus log 3 minus 3 log, well, that's a k, but yes. There we go. Ooh. Okay, so this is helpful right here. Isn't this mean the same thing as this? Because the square root of something is that thing to the 1/2 power. So this is probably the easier way to look at this problem, right? So if you see a square root like this, it might be easier to write it like this. So now we can go log 3 plus, well, we could multiply them together, or we could write just 1/2 log 2x cubed, and it'd be the same thing. This would be okay. Well, actually, we should separate this out now, shouldn't we? This isn't the final answer we should write, because I've got log of 2 things right here. So actually, I should write log 3 plus 1/2 log 2 plus, this 1/2 is going to go in front of both of these parts. 1/2 times 3 log x. So I've got 1/2 log 2. So I separated this out. I've got the 1/2 log 2 plus the 1/2 log x cubed. But x cubed, the 3 could get pulled out, so this would really be 3/2 log x. So really, if I would have multiplied like you said, Emma Claire, that's what I would have ended up getting anyway. All right. So just making sure we understand how to separate it out as much as possible. All right. This is what we kind of learned or made sure we knew yesterday. Okay? I didn't call it this name, but technically it's called the change of base formula. The change of base formula says that you can, if you have log b of m, you could take log m divided by log b, and this c could be any number you want. We use it to type it into our calculator because our calculator knows base 10. So it's how we do problems like this, and we started doing them yesterday, right? If I say log 432, what would you type into your calculator real quick? You would just type this into your calculator. Log 32 divided by log 4. So from now on, even if you don't have a cheating calculator that can give you this answer, okay, you just take log this divided by log this. You could use, as long as these bases are the same, it always works. So it doesn't have to be. What do you get, by the way? 2.5? Is that what someone just said? 2.5. By the way, you could have done this one without a calculator, because look at this. You could use any base you want. What's a base that I know log 32 on? 2. 2 would be the easiest, right? Because 2 to the 5th is 32. And so I have to use the same base right here. What's log 2 for? 2. 5/2. So that one I could have done without just typing it into my calculator. As long as you use the same base, that's why it's called the change of base formula. Okay, any base works. It's just we usually just use it to type it into our calculator that knows base 10. So this one, I wouldn't be able to get this one without just typing it into my calculator. Log 5 divided by log 3, because there's no little base I could put here that I know. So what's log 5 divided by log 3? 1.46 approximately. Same thing with this one. I just got to go log 15 divided by log 2.
Hey, I have a question.
Yep.
Do you still use like the squiggly lines if you round it?
Yeah, squiggly lines mean it's rounded. It's close to that. So what is this one? Almost 4?
3.9.
9 what? Oh, okay. 3.90. All right. Okay. Now this one says use the properties of logarithms to evaluate each expression. Now you guys technically could just take your calculator now and you could figure this out by typing it, couldn't you? You could do log 8 over log 2 and get this answer. Minus log 4 over log 2. Since you know this, change a base formula. But what I want you to do is do these by using the properties that you know. Now, first of all, this one actually you could do in your head, couldn't you? What's log 2, 8? This is 3 minus 2, which is 1. But if I use the properties, but Carver's right. This says use the properties of logarithms. The property said to do this. The direction said to use the property. The property says I could make this log 2 8 over 4, which is log 2 2, which is anything is that's where they're the same as 1. Okay, so that's what the directions are telling us. Let's see, even though I don't know this one, I don't know log 2 160. Maybe I'll know it if I use the property. What's 160 divided by 5? So now I have log 2 32, which is 5. All right, on this one I got to go log 4 64 times, right? Because we're adding, putting it together with multiplication. And what am I going to do here? 2 squared. So what's 64 times 2 squared? 28. 2. Yeah. Shoot. What's 4 to the what is 256? I got 4, 16, 64 times 4, I think, is 256. Isn't 4 to the 4th 256? So there we have it. So I didn't need to resort to the change of base formula for these because I could use the properties to figure them out. Here I'd got log 6, 27 times 8. What's 27 times 8? 216. 6 to the what is 216? You'd be able to figure it out pretty quickly because 6 squared is 36, 6 cubed is 216. All right. So here is, we're going to do the homework quiz here coming up. But when you get done, I just like you to try some of these on this page. I'm going to say do odds. Okay? And you don't have to have this done by Monday or anything. I mean, just do this when you get to it. It'll be some extra practice. All right? You can do the whole page if you want, but doing the odds is probably enough practice here. All right, it's the same kind of problems we just did, and this says C problem 1, 2, 3, and 4, which are the kind of the notes that we just did. All right, so I'm going to stop this video.